Hello students, welcome to this lecture on areas related to circles. So in this lecture, we will discuss exercise 11.1. Okay. So here we use stated, otherwise use phi is equal to 22 by 7. Okay. Unless stated, otherwise we use the value of phi is equal to 22 by 7. So in this lecture, basically we'll discuss exercise 1.11.1 and also summary. So let's get start. So in first question, here we have to find the area of a sector of circle with radius 6 centimeter and if angle of the sector is 60 degree. Okay, so we have studied in our previous lecture. There we have studied the areas of a sector of a circle is equal to 360 is equal to theta by 360 into pi r square. Okay, so we here use that formula, and if we use that formula, then we can find the area of this sector. Okay, so here we let OACB be a sector of the circle making 60 degree angle at center O of the circle. Okay, so this angle is 60 and we have given radius OA, this is equal to 6 centimeter. Okay, so area of the sector of angle theta, this is equal to theta by 360 degree into pi r square. So now area of sector OACB, this is equal to 60 degree divided by 360 degree into 22 by 7 into 6 square. That is equal to 1 by 7 into 22 by 7 into 6 into 6. And if we calculate it, then this is equal to 132 by 7 centimeter square. Okay, so the area of the sector OACB, this is equal to 132 by 7 centimeter square. Okay, and now let us move to question number 2. So in question number 2, we have to find the area of a cordon of a circle whose circumference is 22 centimeter. So you know what is the circumference of a circle? Okay, so you know circumference of a circle with the radius r is equal to 2 pi r. Okay, and we need to find the area of cordon of a circle. So let us see how to solve it. So first of all, we take this circle with radius r. So let the radius of the circle be r. So now circumference 22 centimeter given. Okay, so now we know circumference of a circle with radius r is equal to 2 pi r. Okay, so it implies 2 pi r, this is equal to 22. Okay, and it implies r is equal to 22 by 2 pi, and this is equal to 11 by pi. And now we need to find the area of the cordon. So this is 1/4 of this circle. So this is one cordon of this circle. So cordon of the circle will subtend 90 degree at the center of the circle. So this is our center of the circle, and here this portion is called cordon of this circle, and this cordon of the circle subtend 90 degree angle at the center of the circle. Okay, now area of such cordon of the circle, this is equal to 90 degree by 360 degree into 5 r square. That is actually we have formulated we have calculated the formula for areas of a sector at angle theta, that is equal to theta by 360 degree into pi r square. Okay, so this cordon of this circle is basically sector of the circle. That is why we use this formula, and the angle subtend angle 90 degree make with center is 90 degree. That is area of such cordon of the circle is equal to 90 degree by 360 degree into pi r square. Okay, and this is equal to 1 by 4 pi into 5 into 11 by pi whole square. Okay, and this is equal to 121. This is also 5. Okay, so 11 by pi whole square. So this is equal to 121 by 4 pi. That is equal to 121 into 7 divided by 4 times 22. So here basically we take the value of pi is equal to 22 by 7. Okay, so now this is equal to 77 by 8 centimeter square. So area of such quadrant of the circle, that is equal to 77 by 8 centimeter square. Okay, now let us move to question number 3. So in question number 3, here we have to find the length of the minute hand of a clock is 14 centimeter. That is given to us. Okay, and we need to find the area swept by the minute hand in 5 minutes. Okay, so visualize the clock, wall clock. Okay, and we have given the length of the minute hand of a clock is 14 centimeter. That is given to you. Okay, and you have to find the area swept by the minute hand in 5 minutes. Okay, so let us see how to solve it. So suppose this is your, so we know that in 1 hour, that is there are 60 minutes, and the minute hand rotates 360 degree. Okay, and in 5 minutes minute hand will rotate 360 degree divided by 60, that is equal to 360 degree by divided by 60 into 5, that is equal to 30 degree. Okay, and therefore the area swept by the minute hand in 5 minutes will be the area of a sector of 30 degree in circle of 14 centimeter radius. Okay, so we get this idea. The area swept by the minute hand in a clock in 5 minutes will be the area of the sector of angle 30 degree in a circle of 14 centimeter radius. Okay, so now area of sector of angle theta, that is known to us, that is equal to theta by 360 degree into pi r square. And now area of sector of 30 degree, this is equal to 30 degree by 360 degree into pi into r square, that is pi into 14 into 14. Okay, and this is equal to 30 by 360 degree into pi by 7, 22 by 7 into 14 into 14. So here we basically take the value of phi is equal to 22 by 7, unless it's stated. We have studied in our first slide on this lecture, unless stated, you can take the value of phi is equal to 22 by 7. Okay, so we take here the value of pi is equal to 22 by 7. So if we calculate it, then this is equal to 22 by 12 into 22 by 12 into 2 into 14, and this is equal to 11 times 14 by 3, and this is equal to 154 by 3 centimeter square. Okay, so therefore the area swept by the minute hand in 5 minutes is equal to 154 by 3 centimeter square. Okay, and now let us move to question number 4. So it said to us a chord of a circle of radius 10 centimeters subtends a right angle at the center. Okay, and find the area of the corresponding minor segment, major sector, and here use phi is equal to 3.14. Okay, so we know formula for area of minor sector, minor segment, and we know major sector is equal to phi r square minus area of minor sector. Okay, so now let us find. So this is our circle with center O and radius 10 centimeter, and this shaded region is called minor segment, and this shaded region is called major sector. Okay, so this is minor segment and this is our major sector. So we need to find area of this minor segment and area of this major sector, and this angle is given to us 90 degree. So here we let AB be the chord of the circle subtending 90 degree angle at center O of the circle. Okay, so area of major sector OADB, this is equal to 360 degree minus 90 degree divided by 360 degree into phi r square. Okay, and here the radius is equal to 10 centimeter. So now we can put the value of r is equal to 10. So then you get this is equal to 270 degree minus 270 degree divided by 360 degree into phi into 10 into 10. And here we have to take the value of phi is equal to 3.1514. Okay, so then this is equal to 3 by 4 into 3.14 into 10 into 10. That is equal to 235.5 centimeter square. Okay, so therefore the area of major sector OADB, this is equal to 235.5 centimeter square. Okay, and now we need to find the area of minor segment. So this is our minor segment. Okay, and now we need to find the area of minor segment OACB. So this is equal to theta by 360 degree into pi r square. Okay, so area of minor sector is OACB, this is equal to 90 degree by 360 degree into pi r square. That is equal to 1 by 4 into 3.14 into 10 into 10. And this is equal to 78.5 centimeter square. Now area of triangle OAB. So now area of this triangle OAB, this is equal to 1 by 2 times OF into OB. That is equal to 1 by 2 into 10 into 10. And this is equal to 50 centimeter square. Now area of minor segment ACB, this is equal to area of minor sector OACB minus area of triangle OAB. Okay, and we found the area of minor sector OACB, this is equal to 78.5 centimeter square, and area of triangle OAB, this is equal to 50 centimeter square. Okay, so this is equal to 78.5 minus 50, that is equal to 28.5 centimeter square. Okay, so the area of minor segment ACB, this is equal to 28.5 centimeter square. So area of major sector is equal to 235.5 centimeter square, and area of minor segment, this is equal to 28.5 centimeter square. And now let us move to next question. So in next question, here we have in a circle of radius 21 centimeter and arc subtends an angle of 60 degree at the center. Okay, so we need to find the length of the arc and the area of the sector formed by the arc and area of the segment formed by the corresponding chord. Okay, so area of the segment formed by the corresponding chord. So let us see how to find length of the arc, area of the sector formed by this arc, okay, and area of the segment formed by the corresponding chord. Okay, so let us see how to solve it. So here we take this circle with center O and radius 21 centimeter. So radius r of this circle is equal to 21 centimeter. So angle, and also we have angle subtended by the given arc is equal to 60 degree. So this angle is basically 60 degree. And now length of an arc of a sector of angle theta, this is equal to theta by 360 degree into 2 pi r. Okay, so we know this formula. So length of an arc of a sector of angle theta, this is equal to theta by 360 degree into 2 pi r. And now length of ACB, this is equal to 60 degree divided by 360 degree into 2 into 2 by 7. Okay, into 21. So since here theta is 60 degree, so we put this value in this formula, and we get length of arc ACB, this is equal to 60 degree by 360 degree into 2 into 22 by 7 into 21, and this is equal to 1 by 6 into 2 into 22 into 3, that is equal to 22 centimeter. Okay, so area of sector OACB, this is equal to 60 degree divided by 360 degree into pi r square. Okay, so area of sector OACB, this is equal to 60 degree by 360 degree into pi r square. And now this is equal to 1 by 6 into 22 by 7 into 21 into 21, and this is equal to 231 centimeter square. And now in triangle OAB, angle OAB, this is equal to angle OBA, as OA, this is equal to OB. Okay, and angle OAB plus angle AOB plus angle OBA, this is equal to 180 degree. Okay, we know the sum of all angles of a triangle is equal to 180 degree. So angle OAB plus angle AOB plus angle OBA, this is equal to 180 degree, and 2 times angle OAB plus 60 degree, this is equal to 180 degree. Okay, and it implies angle OAB, this is equal to 60 degree. Therefore, triangle OAB is an equilateral triangle. Okay, so triangle OAB, this is an equilateral triangle. Now, area of equilateral triangle, you know, root 3 by 4 into side square. Okay, so area of triangle OAB, this is equal to root 3 by 4 times side square, and this is equal to root 3 by 4 into 21 square. That is equal to root 3 by 4 into 21 into 21, and this is equal to 441 times root 3 by 4 centimeter square. Okay, now come to the area of segment ACB. This is equal to area of sector OACB minus area of triangle OAB, and we find the area of sector OACB, that is equal to 231, and the area of triangle OAB, this is equal to 441 times root 3 by 4 centimeter square. So this is equal to 231 minus 441 times root 3 by 4 semi square. Okay, so now let us move to question number 6. So in question number 6 is said to ask a chord of a circle of radius 15 centimeter subtends an angle of 60 degree at the center, and we need to find the areas of the corresponding minor and major segments of the circle. Okay, so here we use the value of phi is 3.4 and root 3 is equal to 1.73. Okay, so basically in this question we have given radius of this circle, that is 15 centimeter, and angle at the center is 60 degree. Okay, and we need to find the areas of corresponding minor and major segments of the circle. Okay, so now let us find. So here radius of R of the circle is equal to 15 centimeter with center O. So area of sector OPRQ, area of the sector OPRQ is equal to 60 degree by 360 degree into pi r square, and this is equal to 1 by 6 times 3.14 times 15 square, that is equal to 117.75 centimeter square. Okay, so the area of this sector OPRQ, this is equal to 117.75 centimeter square. And now come to this triangle OPQ. So in this triangle angle OPQ, this is equal to angle OQP. Okay, since OA, OP and OQ, they are equal. Okay, and angle OPQ plus angle OQP plus angle POQ is equal to 180 degree, and here we have given angle POQ, this is equal to 60 degree. Okay, so now this implies 2 times angle OPQ is equal to 120 degree, and it implies angle OPQ is equal to 60 degree. Okay, so angle OPQ, this is 60 degree, and angle OQP, this is also 60 degree, and this angle already given to us 60 degree. So this triangle OPQ is basically an equilateral triangle. Okay, so this triangle is an equilateral triangle. So now area of equilateral triangle OPQ, this is equal to root 3 by 4 times side square, and this is equal to root 3 by 4 into 15 square, that is equal to 225 times root 3 by 4 semi square, and this is equal to 56.25 times root 3, and this is equal to 97.3125 centimeter square. Okay, so area of this triangle OPQ is equal to 97.3125 centimeter square. Now area of segment PRQ, this is equal to area of sector OPRQ minus area of triangle OPQ, and this is equal to 117.75 minus 97.3125, and this is equal to 20.5 4375 centimeter square. Okay, so now area of major segment PSQ, that is equal to area of circle minus area of segment PRQ, and here we find the area of segment PRQ, this is equal to 20.4375 centimeter square. Okay, so here if we use this formula, then we get area of major segment, this is equal to 5 times 15 square minus 20.4375, that is equal to 3.14 times 225 minus 20.4375, that is equal to 706.5 minus 20.4375, and this is equal to 686.00625 centimeter square. Okay, so this is the area of the major segment. Okay, therefore area of segment PRQ, this is equal to 20.4375 centimeter square, and area of major segment PSQ, this is equal to 686.0625 centimeter square. Okay, and now let us move to question number 7. So in question number 7, it said to us, a chord of a circle of radius 12 centimeter subtends an angle of 120 degree at the center, and find the area of the corresponding segment of the circle. Okay, so here you use phi is equal to 3.14 and root 3 is equal to 1.73. so let us solve it. So here we take this circle with center O and radius here OS and OT, this is 12 centimeter. So let us draw a perpendicular one ST, OB, we draw OB which is perpendicular to ST. Okay, and it will bisect the chord ST. So SB, this is equal to VT. So in this triangle OBS, here OB divided by OS, this is equal to cos 60 degree, and this implies OB by 12 is equal to 1 by 2, and it implies OB this is equal to 6 centimeter. Okay, and now SB by SO, this is equal to SB by SO, this is equal to sine 60 degree, and this is equal to root 3 by 2, and it implies SB is equal to 6 times root 3 centimeter. So ST, this is equal to 2 times SB, and this is equal to 2 times 6 times root 3, that is equal to 12 into root 3 centimeter. So now area of triangle OST, this is equal to half times ST into OB, that is equal to half times 12 into root 6 into 6, that is equal to 36 times root 3, that is equal to 36 into 1.73, that is equal to 62.28 centimeter square. Okay, now area of sector OSUT, this is equal to 120 degree by 360 degree into pi into 12 square, that is equal to 1 by 3 into 3.14 into 144, and this is equal to 150.72 semi square. Okay, and area of segment SUT, this is equal to area of sector OSUT minus area of triangle OST, so that is equal to 150.72 minus 62.28, that is equal to 88.44 centimeter square. Okay, so the area of segment SUT, this is equal to 88.44 centimeter square. And now let us move to question number 8. So in this question, it said to us, a horse is tied to a peg at one corner of a square shaped grass field of side 15 meter by means of a 5 meter long rope. Okay, so see this figure. So here find the area of the part of the field in which the horse can graze. Okay, and the increase in the grazing area of if the rope were 10 meter long instead of 5 meter. So here you can use pi is 3.14. So let us see how to solve it. So from the figure, it can be observed that the horse can graze a sector of 90 degree in a circle 5 meter radius. So area that can be grazed by a horse is area of sector OSCB. That is equal to 90 degree by 360 degree into pi r square. This is equal to 1 by 4 into 3.14 into 5 square. This is equal to 19.625 meter square. Okay, so area of that can be grazed by horse is equal to 19.625 meter square. And area that can be grazed by the horse when length of rope is 10 meter long, that is 90 degree by 360 degree into 5 into 10 square, that is equal to 1 by 4 into 3.14 into 10 square, that is equal to 78.5 centimeter square. So increase in grazing area, this is equal to 78.5 minus 19.625 meters square, that is equal to 58.875 meters square. Okay, so this is the increase in grazing area. Now let us move to question number 9. So it said to us, a brooch is made with silverware in the form of a circle with diameter 35 millimeter, and the wire is also used in making 5 diameters which divide the circle into 10 equal sectors as shown in this figure. Okay, so then we have to find the total length of the silverware required and the area of each sector of the brooch. Okay, so here total length of the wire required will be the length of 5 diameters and circumference of the brooch. So radius of circle is 35 by 2 millimeter, and the circumference of brooch is equal to 2 pi r, that is equal to 2 into 2 into 2 by 7 into 35 by 2, that is equal to 110 millimeter. Okay, and length of wire required 110 plus 5 into 35, that is equal to 110 plus 175, that is equal to 285 millimeter. Okay, so this is the length of wire required. So it can be observed from the figure that each of 10 sectors of the circle is subtending 36 degree at the center of the circle. So therefore the area of each sector is 36 degree by 360 degree into 5 square, that is equal to 1 by 10 into 22 by 7 into 35 by 2 into 35 by 2, that is equal to 385 by 4 millimeter square. Okay, and now let us move to question number 10. So we have given this, an umbrella has 8 ribs which are equally spaced. You can see this figure. So assuming umbrella to be a flat circle of radius 45 centimeter, and find the area between the 2 consecutive ribs of the umbrella. Okay, so let us see how to solve it. So there are 8 ribs in an umbrella. So the area between 2 consecutive ribs is subtending 360 by 8, that is equal to 45 degree at the center of the assumed flat circle. So area between 2 consecutive ribs of circle is 45 degree by 360 degree into pi r square, that is equal to 1 by 8 times 22 by 7 into 45 square, and this is equal to 22275 by 28 semi square. Okay, and now let us move to question number 11. So it said to us, a car has 2 wipers which do not overlap. Each wiper has a blade of length 25 centimeters sweeping through an angle of 115 degree. Find the total area clean at each sweep of the blades. Okay, so here it can be observed from the figure, so that each blade of wiper will sweep an area of a sector 115 degree in a circle of 25 centimeters radius. So area of such sector is 115 degree by 360 degree into 5 into 25 square, and this is equal to 158125 by 252 semi square. So now area of sweep by 2 blades is equal to 2 times this. So 2 times this is equal to 158,125 by 126 semi square. Okay, and now let us move to question number 12. So to one ships for underwater rocks, a lighthouse sprays a red colored light over a sector of angle 80 degree to a distance of 16.5 kilometer. Find the area of sea over which the ships are one. Okay, so you can use phi is equal to 3.1. So this question is for your homework problem. So this is your homework problem. Now in this chapter, we summarize the points that are important for all of you. So in this chapter, we have studied the following points. The length of an arc of a sector of a circle with radius r and angle with degree measured theta is theta by 360 degree into 2 pi r. Okay, and second point, area of a sector of a circle with radius r and angle with degree measured theta is theta by 360 degree into pi r square. Okay, and the area of segment of a circle, this is equal to area of corresponding sector minus area of the corresponding triangle. So I stop here this lecture. Thank you very much to all of you.